Hey guys. Yeah, great to meet you all. I'm Fig, one of the co-founders of Squid, and the goal of this session is for you to be able to let any user on any chain access your application. You should be able to build that in by the end of this session. And that's using Squid, which were built on Axelar. We're going to show you how to build a cross-chain transaction. So Squid allows you to swap any token from one chain to any token from another chain, but also build more complicated transactions on top. I'm going to go through what Squid is, a bit of its architecture. We'll go through some code examples, and I'll show you the widget as well, which is our easy-to-use front end, which you can integrate into your own front end with your own branding in just a few clicks. If you have any questions, we should have some time, so just save them for the end and ask. So Squid, we're 9 people. We just raised a seed round, and we're distributed all across the world. We just work in Discord. We launched our front end a few weeks ago. It was really exciting with a bunch of partners, and so you should, I'll put a link up for it later, but you should try out a cross-chain swap. And we've got a booth just over there, so come say hello. So what differentiates Squid from other cross-chain transaction builders or swaps? And the number one thing is we're powered by Axelar. So security is the number one consideration with cross-chain, like to begin with. If it's not secure, then it's really not worth doing. Axelar is, in my opinion, and I've done a lot of research, the most secure generalized cross-chain solution. Really excited by all the features they're bringing out as well with V2, so you can integrate whatever interop protocol you want. They'll be supporting ZK bridges, IBC is already supported. Single-click flows, so this is, for us to compete with Web 2 or build applications with good user experience, everything has to be done in one click. And so with Squid, whatever transaction you're trying to build, it can always be executed in a decentralized way in one click. Contract calls across chains, that's where it's not just a swap. You can buy an NFT, do staking, whatever. Swaps between EVM and Cosmos, that speaks for itself. There's really no other way at the moment other than through Axelar to swap from any token into the Cosmos. We've got great status monitoring. It's probably one of the hardest things also with cross-chain is this: you have these transactions which span different environments and take a while. So Squid has it's wrapped Axelar's status monitoring infrastructure, and we think it's one of the best user experiences or dev experiences for cross-chain out there. Get gas on any chain is a little magic trick we added recently. So whenever you do a cross-chain swap, you can switch a flag in the API, which allows the user to swap a small amount of their bridged assets into gas on the destination chain. So when they're onboarding from a new chain, they're buying an NFT on a new chain, using a new app. Often the issue is that the user needs to have gas over there to be able to use the app after the cross-chain swap or cross-chain execution. So with this, it's perfect onboarding. You can just onboard anywhere, get gas, and yeah, we made that very easy from the dev side. So Squid is a set of smart contracts on every chain. We route messages via Axelar, and we build those routes for the cross-chain transactions with a backend, which we have, and that's exposed via an API, and we've got a JavaScript SDK for using that. We've got this front-end widget, which I'll show you at the end. We're connected to all of Axelar's chains. We're really happy with the chains we're connected to. I think it's the main ones which all of our users are asking for, and the Cosmos, of course. Really excited about building interchain apps. Security, I mentioned before. We find this is the biggest question that everyone comes to us with. And the best thing about Squid, firstly, Axelar, I'm really happy with the decentralized set of 70 validators right now. It's all permissionless and really, really hard what they've made, really difficult to do. And so really happy with what they've done. But with Squid, the benefit of doing a swap cross-chain instead of a bridge is that you swap from a native token, which has no bridge risk on one side, to a native token on the other side. And what that means is that you're only exposed to bridge risk while the swap is happening. So you can see the route here, sort of our most basic route. You have Matic on one side on Polygon. You swap into Axelar USDC for the bridge, And then while that bridge transaction is happening, you're exposed to bridge risk. And then once it reaches the other side, you immediately swap into a native asset on the other side. So any user who's used Squid before is not exposed to any bridge risk in the future. And this time is so short. It's 6 minutes right now, and we're bringing it down. I'll show you if we have time later to hopefully under 30 seconds in all cases. So the likelihood of getting exposed to a hack during that time is super unlikely. So if any of you have your computers up, you can code along. It's super easy, or just at least get the repo up so you can look at the code. But this is our examples repo. Our docs. I'm not sure if I put a link up there, but you can find us at docs.squidrouter.com, so you can have a look there as well while we're talking. But pull that up. That's what I'm going to be working with. So the first example is just the basic cross-chain swap. And I'm going to get into VS Code. So once you've cloned the repo, just run an npm install, and everything should work. You've got these folders on the left, which each one is a different use case, which I've done an example for. And the first one we're going to do is a cross-chain swap. So, all right, I wonder if that's big enough. Maybe I'll try to make it a little bit bigger. Okay, so just go to the index.js file. So the first thing to do is you just import the Squid SDK. Import ethers. You can use whatever you like. Don't have to use ethers. We've set up some config here. I've got a .env installed, so you can put your private key in there and put your RPC endpoints as well. That'll all load up, and you can start to see the parameters that we're going to use, the addresses there. So these are the chain IDs you'll be able to find in our docs, or just they're standardized across every platform, these chain IDs. So the first thing, you need to get the Squid SDK. We've got this little function to get it using our base URL for mainnet. You're going to set up your signer, your provider, which is like setting up MetaMask in your front end. We're going to init the SDK, which is just with squid.init. The first thing to do is to get a route. So the route's super simple. It's just, what do you want to do? It's your from chain, from token, and from amount that you're sending, and then your to address, to chain, to token, and slippage, just what you'd expect. You can see all the types in our docs if you want. We also have a lot of optional parameters, which you'll find in our docs, like the custom get gas with your swap feature, which I talked about. You can add that in. So you get a quote, and they'll return an object called the route object. Then you pass in your signer and your route object to the execute route function on the Squid SDK. All this can be done just via API, via Axios, or whatever you're using. And then, we wait for the execution on chain. That'll submit it to whatever the source chain is automatically. And then the transaction hash is what you can use to track it later. So I don't know if you're familiar with Axelar Scan, but it's a really amazing block explorer Axelar have built. And we use a combination of what they've built, and we add some swap functionality on top. So let's run the code. Let's see. So just make sure we're in the right repo. Cool. So node. So it's a knitted squid. It should be submitting on chain right now. There you go. And here you can see the Axelar Scan URL. Put that into the browser. And you can track the transaction here. So I think the parameters we're probably swapping, the native token, so AVAX to the to DAI on Polygon. So we should receive DAI on the other end, and you can see Axelar Scan here shows you the the progress through their network. So they approve it cross-chain, and then they also execute it. Gas paid there means paying for the cross-chain gas. And the way Axelar works is you pay for source chain gas as usual, just with MetaMask. And then Squid automatically works out how much gas you need on the destination chain, and we route, as part of our API call, we set the value to exactly what it should be to pay for gas on destination. And that's what gas paid is. You can see that exact transaction, just the gas being paid. Call's been approved, which is the verification, and that should be executed fairly soon. We'll go back to it later, I think. Squid also has a status endpoint here, which I'll just put into the browser to show you what it looks like. So you can see all of the things you need for the front end. We track if there's been enough gas paid, because if there's a gas spike on the destination chain, then you may need to pay more. Squid currently overestimates the amount of gas, so the user pays maybe 50% or 100% more, and they automatically get refunded all of the gas that they didn't use. So that's a great feature of Axelar. And you can track that at least using our status endpoint. Destination executed should be finished. There you go, executed. All right, so now the fun stuff. Once you've got a swap down, what are we going to do next? We can do it to the Cosmos. So doing a deposit to the Cosmos is super simple. It's exactly the same as a cross-chain swap, but you set the destination chain to be a Cosmos chain instead. So you can see here, it's all exactly the same, but we've set the 2-chain as Osmosis and the 2-token as USDC. So what this will do is swap into USDC on Osmosis, and we support any Cosmos chain via IBC. Soon we'll have full swaps on IBC as well. All right, I won't run that one as an example, but here, let's buy an NFT cross-chain now. This one I was so excited by when we first did it. All right, so just go into the buy NFT from any chain, and then it's the same as all the others. You just run an npm install and then node index.js. I won't run it yet, actually. I'm going to show you the code. Okay, so buying an NFT across chain, what's happening under the hood is we're going to buy an NFT on Treasure, which is on Arbitrum. I'm not sure if I've got it open here. Yeah, this is the NFT we're going to buy. So it's a rock, and it's just the cheapest thing we could find, but it was fun. So usually on Treasure, you would buy this with your Arbitrum wallet. So you can see I've already bought 13, but I'm going to buy another one. You can buy it, and then once you, actually no, I don't need to, I might as well. What will happen is, this is the purchase transaction on Arbitrum, like just a single chain one, and the easiest way I found to integrate is you just look at the interface, look at all the parameters that get passed in, and you can just grab all of these, so you can see all the parameters for buying the NFT. And then what you do in Squid is you use ethers to, let's see, where is it? This is to encode the data. Here we go. So these are all the parameters here, like the NFT address, token ID, owner. You can see them all matching up. I don't know, it's a bit blurry on the screen, but all those parameters that RVScan's showing are the ones that I'm putting into the interface. So I've copied just put the ABI in, instantiated the interface and ethers, and then drop all these parameters in just to get a proof of concept up. So we're going to set the token that we're buying, the price, and then you use encode function data to encode the buy items call. And now putting it into Squid, what you can imagine Squid is happening behind the scenes is we're doing a swap into Magic token, which is what you need to buy the NFT with. And then once you're on Arbitrum, you need to do exactly just what you usually would normally do. You need to approve the Magic contract to use your tokens. You need to buy the NFT. And then for us, there's one extra step because you're doing this via the Squid smart contract on Arbitrum side. The Squid smart contract will have bought the NFT and it owns it. And then once you have the NFT and you're in the contract, you need to transfer it to the user. So we have a transfer call as well. So I'll show you those. So if you guys are familiar with ethers already, this should be really simple stuff. You can see we've created the approval step, which is just we instantiate the ERC20 interface, call approve, and then put in the treasure address, so we're approving the treasure contract to use the tokens from the swap. And then what's next? We've got the buy call, the approve, the buy call, the transfer of the NFT, same thing. And then one thing we do at the end is we can send, because you don't know exactly how much you're getting from the swap, then there's going to be a remainder left over likely. So say the token costs 1 magic. We want to be able to swap, we need to set a swap slightly higher so that if there's slippage, they get at least 1 magic. So likely they might get 1.05 magic, something like that. So we add another call at the end, which transfers the remainder to their wallet. So they do a swap, they buy the NFT, all the extra tokens that haven't been used get sent to their wallet. And let's just run it now, so it's happening in the background. But there's some details here now that I can show you a little bit more detail. So another issue, oh wait, actually let's jump into Axelar scan. Get this going. All right. So, also because of the non-deterministic nature of the swap, we can't encode exact call datas in advance. We need to be able to patch the amount that's been received from the swap exactly into all of these calls on the destination chain. So what it means is the approve step and the buy NFT step, they can be constant because the NFT always costs the same amount. But the steps later, where we send the remainder to the user, we need to grab the balance, the exact balance that's been received from the swap, and patch that into the call data to do the transfer at the end. And the way Squid's done this is by creating a multi-call contract with a specific function which lets you replace specific argument with the full balance of an ERC20 token or the full native balance of the contract. So you can see this happening in the last call probably. The NFT, no, let's do this one. So this is the transfer. So this call data which has been added is just an ERC transfer with, I can show you it actually. We've set the amount of the transfer to 0. So if this was unchanged, it would transfer 0 tokens to the user's address, the signer. But what we've done, you can see this input position, this is what this payload object is. So you set the input position is 1, so it's a 0 index. If you look at the interface of the, actually no, not magic token, transfer. Not that one, this one. So you can see the second argument is the amount we're transferring, so we need to replace the data in that second argument, which is index 1. So in the background, the Squid multi-core contract will pull the balance of the full balance of the magic token, and then it'll place that into the argument at position 1. So before calling the transfer, it will replace the amount it's transferring, and then it will call it. So what that means is you can really use these swaps with any application. So if you wanted to stake your full balance as well, you could stake your full balance, or you can do it with native as well instead of ERC20. You can see we've got a call type up here. So if you change that to squid call type dot full native balance, we do the same thing for native. Okay, so let's see if it worked. You see it took 1 minute, and I hope it's worked. Demo failure. Hey! Cool. So you can see all these calls happening, the ones that we've programmed in. So the first one's Axelar USDC to USDC to wrapped Ether to Magic. That's the swap which Squid's API built. That's the route. And then the last ones, these 4 last ones, are probably the approval step, the buy, the transfer, and maybe the transfer the remainder. And then in my wallet, it's probably hard to tell because I already have so many rocks, but I might have 14 now. Let's see. Oh, I should have 15 because I bought one. Yeah, I got 15. So yeah, I'm so excited by this. If you have any NFT application, and what it means is you can now accept payments from any chain, and any user, no matter what tokens they have in their wallet, they can buy an NFT. So if you're a fiat on-ramp, you can plug this in as well, so you can go fiat through us to any NFT on any chain. Yeah, super exciting for us. I have an example for staking as well, but I think that's probably enough for now. I'll go back to the presentation. Okay. Nice. So, yeah, I've already said, but super exciting use cases. You can build cross-chain NFT marketplaces, cross-chain DeFi. GameFi also is a great one because a lot of game users don't really want to deal with crypto, and they don't have to think about what chain it's on with us if you're using us in the background. Wallets as well. So you'll see how we're thinking about UX with our front end, which we've built. So if you want to go to app.squidrouter.com on your phone, you can check it out. Let's see. So what we found is that we built this SDK, but people are having hard enough time understanding what a swap is, let alone compared to a bridge, let alone actually building an app. So we built it ourselves, and I'll show you the customizer that we have. You're able to put your own skin on it, put your branding. It's got CSS IDs, so you can change it quite a lot. But this is a full sort of end-to-end swap app. And I'll show you the chains. We can do an example swap maybe. Let's just put a tiny amount in from Avalanche to Celo. I feel like. So we can set the slippage, set the approval amount, I think, and then we'll get a quote, show you the all the normal DEX parameters. You can see the gas fees before refund. We give you fairly good resolution on that. So we have a prediction of how much the source chain gas costs will be, how much the cross-chain gas costs will be, and the cross-chain gas costs will be refunded over time. And Squid doesn't charge any fees right now, so users are just paying gas. We've got these beautiful animations which we love. Confirm that. And I don't know if you guys have seen, but we have, if you share, I won't click it, but if you want to try it, we have AI generated poems for the exact swap. So if you put in your token in your chain that you've sent from, and you can share that to Twitter. Yeah, so that should go through. Now I'm thinking, let's do, okay, so a feature which we're really excited to be building or releasing soon is what's called GMP Express, so General Message Passing Express. And Axelar have built this. We're working with them on it. And what it is it allows you to do almost instant cross-chain transactions from any chain. Usually Polygon has about a 6-minute finality, and Ethereum has 15, Arbitrum has 30. So the transactions take at least that long. But with this feature, you should get them in about 20 seconds as soon as the source chain transaction's completed. So let's just refresh it. Oh no, there you go. So I'll try doing it from Polygon today because Girly's a bit broken. This is just on testnet. Let's put in a small amount. testnet's a bit slower. All right. Okay. All right. This is a bit nerve-wracking. Okay, so it hasn't submitted. We'll wait until it's successfully submitted to Polygon, then we'll open up Axlar Scan. So this is live on our testnet now. If you go to testnet.app.squidrouter, you can try it out. Polygon's taking a while. There we go. Okay, let's see how long the cross-chain transaction takes. So in the background, this is using Axlar's full trust, like decentralized infrastructure as a fallback, and it has we have market makers who fulfill the transactions optimistically. So, oh, there you go, it's already done. 20 seconds from Polygon. So we're going to have that from every chain, and it'll be the same. You'll be able to buy NFTs with 20 seconds from any chain. You'll be able to stake from any chain in 20 seconds. Off-ramp in 20 seconds. It's, yeah, super, super exciting. And yeah, what's happening behind the scenes is there's a normal Axlar message being passed, which does take 30 minutes, but we have market makers who see the payload on the source chain that's meant to be executed, and they execute the exact payload on the destination chain for you. They're providing the bridged token, like Axlar USDC, out of their own wallet, and that gets executed. The user gets their funds, and then the market maker registers that they've executed this exact payload and provided the funds on a wrapper of the Axlar gateway. And so when the bridge tokens finally come through, instead of getting sent to the user again, it just gets diverted off, and the market maker gets paid back the exact amount that they provide. So it still has, from the user's point of view, there's no extra security risk. The only person taking risk is the market maker, that if the bridge transaction fails for some reason, they lose their money. Yeah, so I'll show you the widget customizer too. I might have questions soon as well if anyone wants to put their hand up. Yeah, this is the customizer where you can change your branding, change the branding. You can put your own logo here. You can customize it however you like. So, yeah, we can see Spooky Swap have done a really good job of customizing this. Let's change swap. You can see they've got a cross-chain swap now, and that's the widget working in production there. And this widget is also super easy to install. You can see on the on this page here, this is actually the actual code you can put into your app to install the widget. So you need to install an npm package, and then this code will we'll put it in there. We also have an iframe if you don't have React. It's a React component, so yeah. But we found it works with most teams that we've worked with, so you should be able to use the React version. I don't know if I have anything else. We might move on to questions, I think. Yeah. Does anyone have any questions?
Hey, I have two questions. One is, how do you deal with liquidity issues with cross-chain swaps? Do you have like any max limits or so on?
Yeah, right now we have a max limit of, it's 30K per transaction, but that's only because we've just launched a few weeks ago. Theoretically, you can swap as much as is on the curve pools that we use. So all of our liquidity is on, we've got partner dexes in different chains for stable swaps. And that's the, so these pools here, the Axlar USDC to USDC ones are the ones that are where we might be the limiting factor, but the best thing about Squid is that all of the liquidity is on existing dexes, so we don't have to have our own liquidity per se. It's just we can use everything in Uniswap and QuickSwap and everything out there as if you're a normal user, choosing the best route. These pools have so we've got partnerships in every chain. Currently, yeah, it depends on the chain. So if the bigger chains like Polygon have really large pools, but the smaller chains like Celo might have smaller pools. So the best thing to do is to just go onto the app and see what the slippage is for each size. Generally, you should be fine around above 100K. So yeah.
Okay. And the second one is in cross-chain swaps from NFTs. What happens if, for example, the NFT gets bought from another user? Do you lock the funds on some contract or?
Yeah, so what happens, we have a fallback. So in our contracts, if any of the calls in a multi-call fail, then the whole transaction reverts and we send the USDC that's been bridged to the user's address. So yeah, that's...
Thank you.
And then, yeah, exactly. Any other questions? Oh.
Can you talk about more on the market maker?
Yeah.
What's the market maker like? So in this diagram, like you have Axeler bridge.
Sorry, could you just hold them?
Oh yeah, sure.
Yes, yeah.
So can you tell me more about like the market maker? Like here in the Axeler bridge, you're connecting from stable swap like curve to stable swap like curve on the destination chain. What's the market maker play here? What's the role of market maker?
Yeah, so in this route, there's no market maker involved. It's all via AMMs. So it's all decentralized. There's liquidity providers on all these AMM pools, but everything is just executed through DEXs.
Okay, but for the GMP, you demonstrate the market maker.
The Express one.
Right.
Yeah, the Express one. What was the question around that then?
So what, like, how does market maker do? Like, is this the Axeler? Like, in this diagram, where does the market maker fit in this?
Yeah,
diagram?
so the market maker sits just here on the just before, just where Axeler would execute normally. You think of Axeler like our execution and Squid being the payload generation. And the market maker is sort of optimistically doing the execution for us. So the market maker sits before like where Axeler would be, and they give us Axeler USDC and execute the payload for the user. And then they're also sitting there when the USDC pops out of the Axeler side, it gets sent back to the market maker instead of to the user.
Gotcha. But for market maker, like, would it be a centralized?
Would it be a what? Sorry.
Centralized solution.
Yeah, the market maker is a centralized solution, so that can be censored. That has, I don't know what other risk it has. I guess it could run out of liquidity, but the thing is that if the market maker never submits a transaction, you'll still get the execution as normal with Squid currently. So Axeler will, if the market maker disappears, then Squid will, or Axeler will execute the swap after the 6 minutes has passed. Does that make sense?
Yeah, that makes sense.
Yeah.
Thank you.
Yeah, no worries.
Thanks. And in terms of delays, how do you deal with that? Because of course, in terms of delays, timing, of course, there's a lot of bridging involved between different chains and, AMM getting liquidity. So how do you deal with that, and how is the perception of like the end user when it comes to that?
Yeah, sure. So the main issue with delays is slippage, because you're quoting for a price at a certain time, and then maybe if you're waiting 30 minutes, then the price might have changed by the time the execution happens. Really, our best answer to this is this GMP Express, which I think is gonna it'll improve reliability for everything. But I mean, currently we have we set slippage dynamically in our backend, so you have good slippage on the destination chain, and you can also set it dynamically. So if you're going from a short finality chain, then you can be more aggressive. But yeah, I think once this Express feature is in, you're going to be able to essentially do single chain slippage. But for now, we have a slightly wider slippage because of that.
Thank you. And one last question is, when it comes to all the AMM involved, how do you deal with the fact that liquidity can be dry in those, right? So.
Yeah, well, that's where our routing backend comes in, because every time we generate a route, we check all of the AMMs and choose the best one. And it's not just, it's concentrated liquidity as well, yeah. So unless you could have your liquidity dry up in the half an hour coming from Arbitrum, but that's worst case, so yeah, it's probably not too bad.
Thank you.
Just curious, how many projects are building using your SDK? Is it because you said you just recently released, so I was just curious.
Yeah, I don't have a number. I'm in a lot of groups. There's a lot of people building with the SDK. The widget's the most popular thing, though. because people just want to add the ability for any user to onboard into that app super easily, and they can just pull up a widget into a tab somewhere. But yeah, we have I don't know, it's in the tens. Yeah.
Hi. I just wondering if a stable swap, stablecoin AXL USDC, is issued by Axelar, or can it be used for some other tokens that are on different chains? They want to mapping those. Just want to know who are mapping these like synthetics that are moving around on the backend.
Yeah, so in the back end, everything's done by Axelar. So it's always Axelar USDC moving around. But as you can see in our widget, that, I'll go this one. That Moonbeam's a great example. So on Moonbeam, the canonical bridged asset is Wormhole. So you can see USDC Wormhole there. But we can let you get Wormhole USDC by bridging Axelar USDC and swapping it into Wormhole USDC.
Okay, it makes sense. I have a following question. So, if you want to do, would you be able to support other synthetic assets like native assets on Ethereum or
Yeah, exactly. Yeah. So,
but that have to be like from the Axelar side issuing those, right?
Say that last bit again.
So, instead of USDC, can it be like Ethereum? Or,
you mean in the bridging step?
Yeah, AXL ETH or AXL, something like that. Who are issuing that?
Yeah, so we don't support that yet. I think it makes the most sense to have Axel USDC as the bridging token, and then use that to buy whatever you have.
I see.
Because the reason is that you can concentrate liquidity onto one pool. If we were to bridge other tokens, then we'd need to split it out into, like, say, we'd need a pool specifically for Axel ETH, Axel DAI, Axel USDT. But instead, we put all the liquidity considered in this one sort of bridging pool, and then we swap into everything from there. Yeah.
Thank you.
Yeah, but we're working with Osmosis to build cross-chain swaps, and they have liquidity on all these bridged assets, so you'll be able to swap through Osmosis soon. Yeah.
So I have one more question. So is it okay to, do you guys expose the general message passing through your contract? Or it has to be like token swaps?
Do we? Yeah, exactly. So we expose GMP as usual.
Okay.
Yeah.
But can we send like arbitrary call data to your contract?
Yeah. Oh, you can? Yeah. Yeah, you can do whatever you like to our contract.
Okay.
I think it makes the most sense to do a swap and then do something else. But we have the multi-call, it's a cross-chain multi-call that you can use for anything if you want. Yeah.
Good.
Yeah. No worries. Thanks for having us, guys.